And what is the exponent? 3, perfect. So what does 4 tell us? Yeah. 4 is the number that we're going to be multiplying by itself, right? And then what does 3 tell us? So the 4 is the number that we're going to be multiplying by itself, and then like what you said, the 3 tells us to do it 3 times. Multiply 4 times 4 times 4, right? Okay, and then what about this? What is the difference between 2 to the 3rd power and 2 times 3? What is 2 to the 3rd power equal to? That's 2 times 3. 2 times 3 is equal to 6. What's 2 to the 3rd power? How do we write that in expanded form? Times 2, yeah. So we multiply 2 by itself 3 times. So 2 times 2 is 4, and then 4 times 2 is what? 8, yeah. So 2 to the 3rd power is 8. 2 times 3 is 6. Right? So now what I want you guys to do is we're going to work through all of these problems down here. And the first one they started for us, so let's do that. So they gave us this problem, 2 to the 2nd power times 2 to the 3rd power. And then they wrote that in expanded form. Expanded forms means you just take it one by one. Did you have a question? Yeah, exponential, you had it right. Yeah. So exponential form is going to like simplify it a little bit. So in this part, we have the problem. We have 2 to the 2nd times 2 to the 3rd. In expanded form, we did exactly what it sounds like. We expanded them out. So 2 to the 2nd becomes 2 times 2. 2 cubed, 2 to the 3rd becomes 2 times 2 times 2. So the whole thing becomes 2 times 2 times 2 times 2 times 2. So then in exponential form, we're going to simplify this. So how would we write this using exponents? How many are there? Yeah, so it's going to be 2 to the what power? 2 to the 5th. Yeah. Okay, so then let's look at the next one. So we've got 3 to the 4th power times 3 squared. So I'm going to write that just the way they did in expanded form. So that's 3 times 3 times 3 times 3. That's 3 to the 4th times 3 times 3. That's 3 squared. So then what's my answer going to be in exponential form? 3 to the 6th. Okay. You guys got it? You want to keep going? Mm-hmm. Yeah. Okay. Yeah, just grab your stuff then. Um, no, we just did the first part of it. Yeah, yeah, and I'll post it. Yeah. Good, that's great. Try work on this one. Bye, feel better. Yes. Yeah. So if it doesn't have a number, then it's just one. Cool. Okay. Right. So when you finish with that one, move over to the next side. We'll talk about it in 1 minute. So the next side over here, we're talking about power to a power, an exponent raised to an exponent. Again, this is stuff we talked about yesterday, but I just want to review it with you. So for this first one, we have 2 cubed, 2 to the third power, raised to the second power. So 2 cubed squared. So that means it's like 2 cubed times 2 cubed, which is 2 times 2 times 2 times 2 times 2 times 2. So how do we write this in exponential form? How many 2's are there? 6. So it's going to be 2 to the 6th. Now let's do the next one. We've got 2 squared cubed. So I'm going to take 2 squared and multiply it by itself 3 times, which is like saying 2 times 2 times 2 times 2 times 2 times 2. What does that equal? What's that going to be in exponential form? How many 2's are there? 6. So yeah, again, 2 to the 6th. Is that clear? Questions? Okay. Let's go on. The next one, we have 2 squared to the 4th power. So we're going to have 4 2 squareds. So that's going to be 2 times 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 2. So how many 2's are there now? 8. Yeah, this is going to be 2 to the 8th. You got it? Want to keep going? Or do you want more examples? You don't have to do number 5 because that's just a repeat of number 3. Saves you from writing some extra 2's. Hmm? So I just want you to write the expanded form and then the exponential form. So what is our basic rule when we're multiplying numbers with exponents? What's the rule that we need to follow? If 2 squared times 2 to the third ends up being 2 to the fifth, what did I do with my exponents? Huh? You added them. Yeah, what's 2 plus 3? 5. So it became 2 to the fifth. What about, what's 4 plus 2? 6. So it became 3 to the sixth. What's 2 plus 5? 7. So it became 4 to the seventh. What is 2 plus 4 plus 3? 9. So it became 5 to the ninth. So when we are multiplying numbers that have exponents, we need to add the exponents. And then over here, what did we do to get to this, to get to the final answer? What did we do with the exponents this time? What did we do with the exponents? Yeah, because 3 times 2 equals 6. 2 times 3 also equals 6. And what's 2 times 4? What's 2 times 4? Huh? 8. So that became 2 to the 8. What's 3 times 3? 9. So it became 2 to the ninth. So if we are raising an exponent to another exponent, we need to multiply the exponents. Right? So let's flip over to the other side. So we're going to look at dividing. So let's look at this first example they gave us. They have 2 to the fifth divided by 2 squared. And then they wrote it as a fraction. Because remember, a fraction is just a division problem written a different way. And then they wrote it out in expanded form. And what we can see when we're in expanded form is we can start crossing things off. Because 2 over 2 is just 1. 2 over 2 is just 1. So how many are left? How many 2's are left? 3. So in exponential form, it's going to be 2 to the third. Let's do the next one. We've got 4 to the sixth divided by 4 squared. So 4 to the sixth, 1, 2, 3, 4, 5, 6 fours over 2 fours. And again, I can cancel out 1 from the bottom, 1 from the top, 1 from the bottom, 1 from the top. How many are left over? 4. So my exponential form is going to be 4 to the 4th. Okay, now this one, 5 to the 6 over 5 squared. 5 times 5 times 5 times 5 times 5 times 5 divided by 5 times 5. Again, we can cancel out 1 from the bottom, 1 from the top, 1 from the bottom, 1 from the top. How many are left over? 4. So again, 5 to the 4th. Okay. So continue going. Work through number 8, writing them out just the way I did, and then canceling them out until you have no more in the denominator, and then write it in exponential form. It's a different one. It's a different one. This is dividing now. We haven't talked about this yet. But I want to see if you can see the pattern. How we go from here to here. What do we need to do between the exponents? No. There you go. Yeah. So what do we need to do to go from the problem side to the exponential form? What do we need to do to the exponents? You cancel them, and what does that end up doing? You cancel, yeah, so you cancel what's in the top and the bottom. Yes. But how am I going to go without, I could skip this step completely. I can go directly from here to here. What do I have to do with these exponents? Think about 5 something 2 equals 3. And 6 something 2 equals 4. 5 something 3 equals 2. What is that something? Huh? So I'm talking about all these in general. We're writing a rule for dividing exponents. So 5 what 2 equals 3, Jasmine? Yeah, 5 minus 2 equals 3. 6 minus 2 equals 4. 5 minus 3 equals 2. So this exponent minus the other exponent gives me the final exponent. So when I'm dividing with exponents, I need to subtract the exponents. That's my rule. Subtract.